Okay, guys, in this video, what we're going to do is take a moment and have a little fun. We're going to create a very simple graphics application by modifying our SDL demo that we've been working with all this time.
Yep.
That has the cute little rotating cube. Right. We're going to modify it so that instead of drawing out a cube, what we're going to do is draw out a detailed grid plane, if you will, with a lot of vertices. And then we're going to add a bunch of spotlights in, and we're going to animate the spotlights.
Oh, yeah.
So that we can see the illumination on the grid floor moving around over time, which is going to be really neat. So it's really just a way to show you how we can now put our light class into good use, as well as maybe sneak in a little animation and just have you do something that's fun and cool.
Yeah. And if you just look over, I'll just show you what it finally looks like.
And this, of course, is going to look really rough, you know, because you guys are seeing this, you know, as it's been compressed through the codec and everything. Right. But this is what we're going for. So you can see, even though it is choppy and slow, we've got these different spotlights that are different sizes. They have different cutoff values. And different exponents, different colors, as they're moving around on the floor. So we're going to walk you through all this. Believe it or not, this is very, very simple.
So let me just exit out of this. And let's get to coding. So
go ahead and run that one real quick, just to show everybody. We're right where we left off with the last video.
All right, we're going to convert this into the light demo. So let me go ahead, and first thing is, as you might have noticed, the plane that we had on the bottom is not textured. So let me go ahead and just disable texture. And then I'll just go down. We can keep loading it just to save time, and just disable our GLBind texture.
Okay.
So with that, let me go ahead and delete out this Q drawing code as well. So let me just kind of delete this out.
Say bye-bye.
And what I'm going to do now is create a new function called drawGrid that's going to draw the main grid that we have in the base here. And we'll leave in our light. As you can see, we've created a spotlight just so we can use it as test.
Sure.
So right above our draw scene, let's create a GLVoid drawGrid. We'll pass it GLVoid. Just staying consistent with our syntax here. Now, what I want to do is be able to specify a width and a height. Let me just type some things out really quick here. A constant float width, and I'll just specify this to maybe 80. And constant float height equals 80. And then I want to be able to specify a number of divisions, so a constant in divisions. And I want to be able to, let me put something in here. Let's say 100 divisions.
Okay.
So what I want to be able to do is create a grid, a plane, if you will, that has a width and a height of 80 in both width and height, and divisions of 100. So I want 100 squares, if you will.
So, matter of fact, why don't we just go ahead and jump over real quick to the whiteboard, and here you go. Joel has now got the whiteboard.
Oh, yes.
So draw us out your pretty grid. Show us how this is going to work. Basically, we're going to have a loop within a loop.
Right. We're going to have a loop within a loop that first draws column and then moves over.
That's right.
So here's what it's going to do. If I just draw this out here, let me draw.
Let's go ahead and say, go ahead and draw out your...
Yeah, I'll put some variables in just a second.
Yeah, we'll do some simple variables. No, we're going to do 80.
So let me do a width of, say, maybe 10, a height of 10, and a divisions of, say, 5. Okay. So D for divisions with 5. And essentially what I want to...
So split up in 5 by 5.
Right. So 1, 2, 3,
4, 5.
4, 5. So 1, 2, 3, 4, 5 divisions. Not even, but you get the idea.
Right.
So how do I calculate this? Basically what we need to calculate is what is this width right here. I need to be able to calculate this. Well, I know the width, and that's going to be 10. We know the number of divisions is 5, so to calculate the increment, if you will, that's width divided by D, and that's 10 over 5, and that is equal to 2, which is equal to our increment in X. And we do the same for height, which would be H over D equals 10 over 5 equals 2 equals increment in Y. So that's the first thing I need to know. So how do I increment it? So once I have those two, I can calculate this as well. So 1, 2, 3, 4, and 5 divisions. And so what I'm going to do is create a loop that first draws this guy. So I have a loop that goes from, and again, we want the center to be, not again, but basically we want the center to be at origin, which is at 0, 0, and I want this whole area here to be width, which is 10. So I want here to be -5, from -5, and let's say this is X, and to a positive 5 in X. And then I want to do the same thing in Y, so from -5 to a positive 5.
Okay.
So to do this, I want to loop from negative width divided by 2 to positive width divided by 2. And then just loop through with the height as well, so from negative height divided by 2 to positive height divided by 2. And just loop through these two, adding on each increment x along the width and increment y along the height.
So if you were going to draw this out as if you were drawing the actual triangle, just basically...
Yeah, I'd draw this first, and then I would draw this guy, then I'd draw this guy, then I draw this guy, and then this guy, and then start back into here, and then here, 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 etc.
Okay.
Does that make sense?
Mm-hmm.
All right, so do you want to go back and start doing the code?
Yeah, let's go ahead and jump over in the code.
All right, so back in our SDL demo here, first thing is, how do we calculate our increment in x and y? So we have our float inc x.
Just like you guys saw a second ago, it's just going to simply be width over.
Width divided by the number of divisions.
And we'll go ahead and cast that to a float.
Yep, so cast our... divided by divisions.
There you go.
Yeah. It's kind of out in la-la land for a second there. And height is just going to be float divisions. So once we have this, we simply do a very easy loop that loops from float x equal to, again, negative width divided by 2.
Same thing you saw over there on the whiteboard.
So you've already seen all the code. We just need to actually implement it. And x is going to be less than width divided by 2. X is going to plus equal inc x. And same for this one. Float y equals negative height divided by 2. Y is less than height divided by 2. Y plus equals inc y. Excuse me. And then inside of here, let me go ahead and put in my brackets, curly braces. All right. So the first thing, we do have lighting in this one, so we do need a normal. So let's go ahead and actually all of these are going to be the same normal. And remember, OpenGL is a state machine,
so we can set it once.
Yep. So we can set our GL normal 3F, and we're going to be on the XZ plane. So Y is going to be pointing up for our normal.
And we can go ahead and specify a color as well out there.
Yeah, let's go. We want it to be black, so let's do a GL color 3F and 0, 0, and 0. All right, so what do we do inside of here? Well, we can have a GL begin, and we're going to draw this as a triangle strip. Now, if you remember from the intro, I believe we told you that basically, if I just quickly go back into the board here, can you go ahead and draw this?
Actually, I'll draw it out for you.
Yeah.
So basically what Joel was talking about is with the triangle strip, we're just going to create, hang on, let's do it this way. So create, and then create, right?
Right.
And so now we have a triangle, and then, but if we create one more point, that's all that's required now, and we get this guy.
Right.
So then that's all that's required. So basically you're just going to create 1, 2, 3, 4. So you're going to create 4 points here using the GL triangle strip.
Right.
And that's going to give you, as you were just showing up here, that first square. So it's really kind of like such.
Yep, exactly.
And then from there we just keep on building.
Mm-hmm.
Okay, cool.
Thank you.
Mm-hmm.
So with that, all we need to do is do a GL triangle strip. And inside of here, do 4 GL vertex calls. So GL vertex 3F. And the first one's going to be x plus inc. We're doing a little bit different than what I showed on the board, but it's basically the exact same thing. Plus inc y. So I'm basically starting at the bottom right and working.
Okay.
But it's the same idea.
Mm-hmm.
And then we have let me just copy and paste this 4 times. And then we have our x plus that, and our y plus inc. Just keeping this a little bit clean.
Sure.
Thank you. And then for this one, this is going to be x plus inc, this one's y, and this one's going to be without that, and this one's the same thing. And this one's going to be without
just
inc.
x.
Yeah. There you go. And then, of course, we have our GL end. So this simple function allows us to create a plane with whatever divisions we specify and a width and height that we specify.
Bottom line is we're just creating columns, then moving over. Column, moving over.
Right.
Column, moving over.
So with that, let me go down to our draw scene here, and let me just delete this line here and type out draw grid.
And don't forget, all of our normals were pointing up and Y.
Right.
It's a plane floor.
Yeah. Let me just delete this because we don't need it anymore. So now at this point, we have our grid. Now we need to go ahead and create our lights. And we do update each of our lights, but we need to go ahead and create our lights down in our main area here. So right here, right after we initialize OpenGL, we need to start creating all of our lights. So the first thing is, let's do a for loop that loops from 0 to the maximum number of lights that we can have. And remember, we called our initialize inside of initGL. So our light class should have num lights initialized to the number of lights that our video card allows us to have. So let's loop through all of these and create a light for each one. So let's do a light equals new light. Let's create spotlights for all of these. And then let's set a few things. Let's set random colors for the diffuse. So how do we do this? Well, let's create an R component. And to do this, let's get a random number. And remember, a random will return, the rand function will return a value between 0 and rand max. So if we want to get a value between 0 and 1, we simply divide rand by the maximum number that we can have, which is rand max. And we need to cast this to float so that it is able to do that properly. And then that's a random number between 0 and 1 for our red component, G component, and B component. So R, G, and B.
Okay.
And for this light, let's go ahead and set its diffuse to R, G, B, and just 1 for our alpha, excuse me. Mm-hmm. And then we'll set our ambient. We did set this. We set this in the constructor, but we'll go ahead and just specify it here as well. Now, if we want to, let's go ahead and set the spot direction to point downwards. So 0, -1, 0.
Of course, again, we don't have to because that is default with the spot type.
It is, okay. But yeah. And let's go ahead and set a random cutoff as well. So we'll simply do, we want a value between 20 and 80. So what we can do is have a 20 plus and use the same logic we used here to get a value between 0 and 1.
That's right. So keep in mind what the cutoff means. Basically what we're doing is we're simply setting a cone angle.
Exactly.
So that each of our lights are going to have different sizes, different diameters.
Exactly. So basically what we're doing here is we're getting a random value between 0 and 1, multiplying that by 60, so we get a value between 0 and 60, add that to 20, so that allows us to get a random value between 20 and 80.
Basically we're doing an offset. We don't want to have cutoff getting a value back of 0.
Right, because then you just get this one little point.
Or like 0.5 or 0.2,
yeah,
something like that.
It looks really weird.
Speck shooting around.
Yeah, it's kind of bizarre. So once we have this cutoff, let's go ahead and do a set cutoff. And as you can see with our class, it makes this very, very simple. We also want to set the exponent. So in other words, the fall off of the cone or the spotlight.
This is really important, obviously. Otherwise, you could end up with something that just looks bad.
Right. And what we're going to do here is set a value of 20. But for those that have larger cutoffs, we're going to increase the exponent.
Right, we need larger exponents.
Right, so we're just going to multiply by the cutoff.
That works perfect.
So that's that. Now, before we forget, we've just created all these new lights, right? We need to go ahead and delete these as well. So at the very bottom, before SDL quit, let's loop through all of these lights, because notice we're not storing them in any global variables. So what we need to do is loop through all of our lights that are stored in our light class. So I equals 0, and then I goes to light, and then size, I++. So we're going to loop through all the lights and delete all of them. So do a lights. So there, we've deleted all the lights. Now, another thing we want to do is we want to move everything around, right? We want to have a little bit of animation, but we want each of the lights to move differently. So let's create a seed value for each of our lights. So let me go all the way back to the top here. So right to here. Let me create an integer pointer.
Go ahead and initialize it to null.
Called seed, and I'll initialize that to null. So basically, seed is going to be an array of size num lights, and it's going to hold a random seed for each of our lights. So if I go all the way down to the bottom, right to here, let me go ahead and initialize this. So seed equals new int, and it's going to hold num lights, as I just said. And inside of here, let's go ahead and initialize this to something. Very simple. Seed I equals random number. Done.
Perfect.
And of course, we're going to need to delete this as well. So right here, let's go ahead and delete seed.
Nice and clean. Excellent.
So we have our random seed. We have created all of our lights. Now inside of our draw scene function, let's go ahead and add some random movement to this. And this is actually really simple since we've already set up everything for it. So right after, it's right here, right before our light updater, let's do a for int I equals 0. I is less than int. Oh, actually, we have it right there. I don't know what I'm doing here.
That was great.
Let me just put this right here.
Okay.
And let me create a random number to be used. Oh, remember, we want this to be driven over time, right?
That's right.
So we want it to change over time. So all we need to do is create a random number.
And we've already seen, if you think way back to our first SDL demo, that we do have SDL get ticks.
Right. In fact, I can show it to you right here.
There it is.
In check keys, we use SDL get ticks to control the speed of our rotation when we use our keys.
So that is a nice changing value.
Yep. In milliseconds. So let's add that. We're going to add seed I so that the random number is different for every single light. Because remember, we're looping through every single light here. And at this point, let's create a random X and Y value. And this is going to look really complicated, but don't panic. It's really, really simple.
You can make it look a lot more complicated.
Yeah, you can if you really wanted to. And at first I did, actually, but I made it a little bit simpler. So we have sine. Remember, this goes between -1 and 1. And what we're going to do is pass it our random number. And remember, this is in milliseconds. So we need to kind of scale it down a little bit so it doesn't oscillate too quickly.
We're basically controlling the frequency now.
Yep. And we're going to change this to divide by 1600.
And this is something you can play with once you've put this together, just to get a feel for what it does with the speed.
Right. And then just to add a little bit more random motion here, we're going to multiply this by cosine. And do exactly the same thing, but with a different frequency. So random number divided by, let's say 1200. And again, like Buzz said, this is something you can play with.
And of course, since we're only getting values of -1 to 1.
Because we have a -1 to 1 value multiplied by another -1 to 1 value.
That's right.
And we want to kind of scale it. In other words, change its amplitude.
Multiply the whole thing by 50.
So that's going to go between -50 and 50.
Exactly.
So let me go ahead and copy this whole thing and do something very similar for the Y. I'm going to change this one right here to 900. And this one right here to 1400. And by simply changing these two around, you get completely different motion for X and Y simply by changing its frequency. And then, of course, multiply by 50. So once we have the X and the Y, we simply need to update the light position. So let's do a lights I dot update position. I'm sorry, set position.
Yeah.
I can do this really. Then set X, and we'll just move the light up to 30, and then set Y. Or we can change that to Z if that makes you happier.
Hopefully by now you guys see that there are all sorts of factors being calculated here that you guys can go in and play with to see exactly what's going on with these couple of lines.
Right. So if I can just recompile this. And, of course, cos and
so
sine.
We need to make sure we include math.h.
I knew I'd forget that. I just knew it. So if I recompile this.
Beautiful.
Let me go ahead and run it.
Whoa.
All right. Here's another thing that is kind of different. Remember, we're zoomed way in here.
That's
and
right.
we have a grid that's, I think, 80 by 80. And it locks as well. So we're going to need to fix that as well.
That's right.
So if I just go down to, let's see. All right. On our draw scene. We have it at -5 at the moment. We need to zoom way back. So what I'm going to do is change this over to -80. And let me recompile that. And I'll fix the whole locking thing in a second here. So what you can see is we have a fairly interesting looking thing going on here. That light just happens to have a bigger fall off than everyone else.
Yes,
or
he does.
a lack thereof. But otherwise, yeah, it's working pretty nicely.
Yeah, it is.
So we got the random movement, the lights moving everywhere. Let me go ahead and exit and find out what's going on with this random crash. Let's see, how is this working here? If we go down to here. Okay, totally remember what's going on now. Remember, we're creating this new light here. So we don't need this extra light. And that's what was causing that extra weird light. So let me go ahead and redo this and check it out.
Much better.
Much better. And there we have weird colored lights. And if you want to randomize this a little bit, because every time it's basically going to start out the same, we just do an SRAN to seed the random number generator. And if we exit now, we don't get an error.
Yeah, exactly. And to be honest with you guys, just kick back and play with this. Try to do things like put a light shining on each of the corners of the grid.
Yeah.
Stationary lights. And then you have your ones moving. Just try different things.
Try directional lights, point lights, try it all out.
Just kind of play in your mind. Picture a concept of a lighting layout. And
play
then
with
see
the
if
attenuation as well.
Yeah, that's a good one. And then implement it. It's even better with the attenuation, though, when you start having objects that are going off in the distance, so we take distance into account.
Yeah.
Here it's more of a play with the exponent and see what kind of cool things you can get. Plus, in our case, Joel, if you want to go ahead and scroll back down real quick to where you actually...
Change the exponent?
Well, I was going to say... Well,
I could change the exponent to 0 or something.
Yeah, let's play with a few things.
Okay.
Just so we can make a few points here.
All right, so if I change the exponent to 0...
Yeah, this will be nice and fun.
Look at that. Everyone is completely hard-edged, and you'll notice... This whole poor vertex lighting thing, well, it kind of drives it home as well, because it's not clean. If this was per pixel lighting, you get really nice, smooth edges.
And if you wanted these smooth, the detail that we would have to have in this plane would just be
insane.
Crazy.
And this is already way more divisions than you would want.
And actually, leave that exact setup. Go ahead and close out of that application and watch this, where we create our grid.
Yeah.
Let's go ahead and change our divisions on that, because that'll make it even more...
something less.
Yeah, exactly.
Okay, so something like...
So let's do 20.
20, okay.
I'm going for something noticeable. Yeah.
Look at that.
There you go. Now you can really see kind of the grid outline as it starts
and how it's it fades between each vertex.
Precisely. So that's really cool.
And if I pause it here, you'll notice that okay, now I can't actually...
You can see the interpolation.
You can see the interpolation if I just pause it right here. And if you look at just around each spotlight, how it interpolates between each vertex.
Right.
So, yeah.
All right, so let's go and up our divisions again. Now let's go back up to... wow.
400, no.
That's crisp.
Yeah.
Now we'll go back to where our little bit of animation is.
Our animation?
Yeah.
Okay. That was right.
I'll actually go back down to the cutoff. Let's go ahead and put the... I'm sorry.
Yeah, it's all good.
Let's put the cutoff back in.
Okay, the exponent. Yeah. And I think I had this at multiplied by cutoff. Okay.
Okay, now we'll go back up to... All right, so up in here...
What if you want to speed this up, let's say?
Precisely.
Let's take away all the zeros.
And let's change the scale on the outside where we're scaling the final result of that. Yeah.
Oh, let's make it like 10.
Exactly. I was going to say, let's tighten it up. So watch what happens here. Yeah, very tight now.
Very tight little lights shooting kind of like a disco.
Yeah.
Yeah.
So you guys see how you can go in there, play with these numbers, and really get a good feel for what is going on. So with that, that's pretty much all we wanted to show you. Like I said, it was just kind of a way to take a break for a few minutes, have a little bit of fun with our new light class.
Right.
See it in action, see how easy it is to define multiple lights. Yeah, make sure it works. I mean, you could say we tested it in the last video.
Just a little bit, though.
But this does give you a good sense of how the whole thing works in a very simple application.
Definitely.
So with that, that's going to wrap up this video. And from here, we're going to go ahead and move into a quick discussion about materials.
Right.
Thanks a lot.